unmute myself. Hi, everyone. Thanks for coming for December's TAC meeting. This month, we do have a couple of agenda we can go through. There are the end of year Urban Community Foundation updates and presentation from Chris from Uber about HubGL, and then a discussion around Mapbox GLJS license change at the end. So some update on this, Gail?
Yes, so for the end of the year, we had the elections reopen for TAC chair for 2021. Sean had been serving us from, I think, around the October timeframe, and she's re-elected and will continue serving as TAC chair for the remainder of 2021. So we're excited to have her keep leading our community. So congratulations, Sean, welcome back.
Great, yeah, happy to keep serving as TAC chair and lead the meetings and discussions. Next agenda is there is a proposal to in terms of how to add TAC voting members, and there's a PR just been put up here. There, the idea is that each project added to the Urban Computing Foundation can appoint a representative to serve the TAC voting member group. So do we have enough people for a vote on this proposal?
We do not have enough today, but we can, if you want to talk through the change, we can get some discussion and get any feedback on it today.
Okay, yeah, so I think we talked about this the last TAC meeting, but the idea is that the original TAC voting member was appointed when Urban Computing Foundation was first announced, and we thought that since time has changed, we added more projects to, in order to get people more involved in the TAC, we should allow the project who are contribute to the Urban Computing Foundation also has a representative to serve on the TAC voting members. So this is a proposal just for that. And, for this way, we will be able to invite Xiaoji from VizGL and Randy, you're already on the voting member, but adding people who wanted to donate projects to UCF has a voice in the TAC agenda.
So are there any questions for Sean or feedback about, making this would be a change to how new committers new voters are added to the overall TAC for urban computing, and this just allows us to have a default for each project having a new member appointed to the TAC as a voting member. So any questions on that or feedback, guys? Okay, I don't see any unmutes, Sean, so I think you're good to keep going.
Okay, so then let's keep going. HubGL, so we have a project presentation today by Chris Gervin from Uber. And his project, he's considering donating HubGL to the UCF. HubGL is a video exporting software that's built on top of DEC, I believe. And I will let Chris take over and present HubGL. Chris, are you on the line?
Yeah. Hey, thanks, Jan.
All right, I'll stop sharing.
Cool, I can share my screen and we can get into it. Hey everyone, thanks for having me. As Shan mentioned, HubGL is a visualization library for animating and exporting videos and GIFs of, primarily VizGL, DECGL, KeplerGL based visualizations, but it's actually a library agnostic solution, so people could extend it to animate all kinds of different libraries. I even have it exporting Mapbox GL stuff and even fusing Mapbox GL, DECGL together. So, there's a lot of potential, and you can see in the background one of the results of last year's use of Hubble GL at the Uber Elevate Summit, where we kind of put hundreds of megabytes worth of airspace data flying around LA and like animated it in 60 frames per second and exported it with Hubble. So anyway, I want to share with you today this library that I was able to open source last year and show you a little bit about how to use it. So we'll go through some use cases, you know, how might you be interested in using it, who would be interested in using it, how people do animation and video today, why I think there are some key advantages that Hubble GL brings into the, you know, those folks' toolkit so they could use this as an additional way to make animations. I have some demos that I'd like to show you. I'll quickly integrate it into an app to show you just how easy it is to bring Hubble GL into a DeckGL application. And then get into a bit of the tech stack, you know, kind of go under the hood, show you a little bit about how the rendering cycle works, and then finally close with the roadmap. So use cases. So primarily, you know, this was developed. I'm a software engineer on the Uber Elevate data science team, and so primarily this was developed out of a necessity for me and my team to communicate what the meaning behind our visualizations are. You know, we're trying to kind of predict or simulate what future aerospace industry could look like. We really want to not do artistic renderings of what this might look like. We would love to actually show people in presentations, whether these be stakeholders at work or people more in the public. We would actually love to show them the data and bring them through the journey of the meaning of that data. And so, you know, primarily data scientists and analysts are the folks that I've used this with. I'm an engineer, and, you know, so on one hand, the use case could be for a data scientist and analyst that doesn't want to do all the specialized programming of animation, but they really would love the final result to use that as a storytelling tool or a communication tool. But then there's the engineers that would love to be able to integrate this, but don't necessarily need to know or want to know all the specialized engineering required that goes into video encoding, rendering life cycles of browsers, all this kind of stuff. So this would be a great library for folks that want to have that be simplified. And then finally, product designers, you know, there's a whole nother end to this. And so I'll go real quick and yeah. So anyway, data scientists, they want to integrate visualizations and presentations. You can kind of see like it is eye-catching, but also informative. And I've seen really great presentations of folks that will break down visualization step by step and lead you through kind of the data. And it draws a connection with the person you're presenting to, contextualizes what you're talking about. And so that's one use. Engineers, yeah, we want to be able to build export capabilities into applications. This is like a Kepler prototype that we've been working on. And then product designers, they want to be able to capture picture perfect visualizations for their websites, demos, product releases. You can see KiwiBot over there. They have a DeckGL visualization on their homepage. In the Uber Air group, we did this neat like demo system at a conference that you could walk into and see, and we wanted to have like, you know, 60 frames per second, no drop frames, visualizations playing. And so that wouldn't have been an appropriate environment for like live real-time rendering. So this is where Hubble can be a really nice product or library to bring in. So how is it done today though? Because, you know, people do currently do a ton of screen capturing with QuickTime to get their visualizations captured. And it's you know, it's great on a couple aspects. It's fast, it's easy, right? It's just built into your Mac. You can just kind of control exactly, you can capture anything. Like that's the biggest benefit to it. But when you're trying to do like really serious projects with it, or trying to do projects where you're doing a lot of iteration, and it starts to fall apart real quick. It's hard to control all the parameters of what you're capturing. There's no repeatability, so it's almost a performance every time you want to try to do a capture. If someone said tweak this one thing and redo it, you can't just redo it. You have to perform whatever you had done before to make it match close. And if the timing of someone's presentation is important, like it gets messy real quick when you have maybe 10 or so little clips that you're stitching together into slides. So the solution kind of falls apart. It's also limited in animation because you're not actually working with an animation framework. You're more just capturing whatever's on your screen. So if you can click and drag the map around with your mouse while having like Kepler's time series kind of playing back, like you're animating those two things. But what if you wanted to animate something entirely different? There's no entry point. And then finally, real-time rendering can drop frames. Whether your computer's slow or just has a hiccup or something, you kind of have to get lucky to get a really polished video out. And this is actually how I did the animations for a previous summit, I think the 2017 Elevate Summit. And we just ended up having to get lucky with getting high quality video out. In most cases, if you're doing something quick, you'll end up with a lower quality, more unpolished look. The other way it's done is with like bespoke software, which I mentioned earlier. Engineers, there are ways to do animations today, but it's highly specialized in the skill sets you need. Not only do you need to know all the stuff on the very left column where, JavaScript, React, Deck, Mapbox, and like animation fundamentals, which is a lot on its own. On top of that, you need to have a really deep understanding of, video encoders, WebGL framing, the DOM rendering lifecycle, web workers if you're doing stuff with that, HTML canvas for capturing pixels, and then device pixels, which varies by screen. There's different densities and stuff. So if you're trying to get like a 1080p video, it's not guaranteed you're going to get that if you set the canvas to a 1080p resolution on like a Retina display, for example. So little time is left over for the stuff that really matters: the creativity, the iteration, the story development, and the like innovation of your actual like visualization. So what if there was a way to minimize the engineering skills required so we could spend more time on what mattered? I really think that where Hubble steps in immediately is it crosses off all these specialized areas that you need to understand, so you have more time to do the work that matters. And so that's Hubble GL in a quick nutshell. It's a library to animate visualizations and export them into video and GIF. I want to show you real quick how to integrate that into a DeckGL application. We'll start with DeckGL's hello world like boilerplate. We have a scatter plot with a single point and a hello world text on the right. And what we're going to make is this animation. This is a GIF directly exported with Hubble, where we're rotating the text, fading it in, fading the circle in, changing the radius scale of the circle, and then kind of animating everything out. So, we'll do kind of a side-by-side comparison. On the left, we'll have the original. On the right, we'll have the Hubble GL version. We'll start by importing a few Hubble GL components. A quick animation is a React component. Keyframes is a keyframe class to help you do some of that stuff. And then from Pop Motion and Hubble, we have a bunch of easing functions, which are basically just ways to make animations over time look really smooth or not. It's up to you. There's a lot of control. Second, same. We're going to have view state on both sides, but we're going to add another constant here. We're going to define what the duration of our overall animation is now. And then we're going to get into some of the more meaty Hubble GL stuff. Here we have the keyframe definition function. The idea is, you'll look here, we have a circle and a text object. Each of those are keyframes. What is a keyframe? You have to kind of basically say, what are the features of the thing I'm going to animate? Opacity, radius scale, opacity or get angle on text. And then you just list out, what are the key states that you want your stuff to get at. So for me, I wanted everything to start with like opacity of 0. You couldn't see anything. The text is at 90 degrees. That's where the -90 is. But then I want to very quickly fade the text in and get the angle to be kind of straight to 0. And so if you look down at the bottom, the opacity going from 0 to 1 and -90 to 0 is that animation. What Hubble and what keyframes do is it'll go in, and when it renders, it'll actually just do all the interpolation between these two states for you, so you don't have to think about that. And then finally at the bottom, you can specify specific timings to go between things. So it'll take 1 second to go from 0 to 1,000 milliseconds to go from state 1 to state 2. And the very last thing at the bottom are the easings. So these are basically the acceleration curves that you can define to go between the two states. So an easing function is basically a function that you can think of it as a function that takes a number from 0 to 1 as an input, but and a step. But what it'll do is it'll just kind of tweak that to give you kind of a pop or a curve or whatever in terms of the acceleration of your motion. Okay, so we're almost there. The last little tweak the big last little tweak we have to make is, on a DeckGL, normally you would define a simple array of layers that you want to animate on the left, your scatter plot and your text layer. In Hubble, you do the same thing, except now you need to define it as a function called getLayers. And what this function will do is it'll run on every frame and actually do the interpolation. And we'll basically go and get from our scene, which is provided by getLayers, grab the interpolated values and spread them onto the layer. So if you have opacity and radius scale, which are like scatter plot layer properties, if they match, you could just easily spread them in. And yeah, just to reiterate, like, we're spreading circle frame. Circle frame is an opacity and a radius scale object. Very simply, it's just some interpolated object along the timeline. And finally, at the bottom of the app, we'll just replace the DeckGL component with a quick animation component. And the props more or less match, but we'll replace layers with getLayers, and we'll add in our getLayer keyframes function too. And here it is all together. So, you can check this out on the website. It's the quick start example in the repo too. So there's many other examples that I want to show you next. Well, first though, I want to talk about some advantages. So, some of the key advantages of this library are that you get to have this programmatic like keyframe animation system. You get guaranteed frame rates and resolutions without any drawbacks, and I'll get into that later when in the tech stack. It's client-side video encoding, so there's like no complex or expensive encoding server off somewhere. This was designed for front-end engineers to build front-end experiences for people, doing stuff in the browser. There's lots of formats. We've shipped already a GIF encoder, WebM, PNG, and JPEG sequence. And then there's finally a bunch of React components for easy integration. So some of the technical design advantages, as I mentioned at the very beginning, it's a visualization library agnostic library. It captures any canvas source. It's slow computer friendly, so it waits for each frame before the render actually captures. It's safe to use. Many existing libraries out there hijack browser timing functions like performance.now or state.now. This doesn't do any of that. And I felt that was extremely important for folks that, are relying on the timing of things in their applications, and they need like a real application running. We can't just be hijacking window and date variables. It's user interruptible. It doesn't lock the UI. It's a very asynchronous promise-oriented architecture. And another benefit of that is if you're halfway through your render and you want to just kind of stop it, you can stop it and save a partial render with any of our encoders. Some cool demos. So this one here is a camera animation demo. In this demo, the user gets to basically control the camera like they would any other visualization, but they have a couple additional features here. They have two buttons called Set Camera Start and Set Camera End. And what those effectively are buttons that capture the view state, the current view state. And so a user is able to set, every time I click on here, I'll play that again. Every time I click on Set Camera Start or Set Camera End, I'm just going to be redefining what the start keyframe looks like and what the end keyframe looks like. And when I render it, it's going to go from start to end and do the interpolation for you. And it all runs in runtime, so it's very dynamic. You can reprogram this stuff and reprogram partial stuff and really quickly get renders out. And you'll also notice that layers are animating with independent timings. So we're independently animating the view state, scatter plot layer, and text layer. You can keep going. There's this, you can even animate individual data points if you want. And here's just some of the, different GIFs that I exported directly from Hubble from this. And this is on the examples website, hubble.gl/examples. So you can play around with this and see what you can come up with. The other one that's another demo that I love is the landmark tour. Last year we were working pretty hard on the terrain layer, and so this is a neat like terrain layer animation one. It's what if instead of letting the user control the story, what if you want to pre-program what that looks like? This is what this example kind of covers how you would do, and then you can also like replace the surface, instead of it being satellite imagery, you could have it be a rainbow. And that's what I did. So, you know, it's a very flexible library, kind of just showcasing how dynamic and powerful the animation plugins are. All right, so let's get into a little bit of the weeds. Let's get a little lower level into the tech stack real quick. I want to talk real quick about some of the, you know, core API for Hubble GL, and then get into some lifecycle stuff. So adapters are a class set that one defines to connect a bunch of things to Hubble GL. So React, Mapbox, DeckGL to Hubble GL. The business logic, the translation between one library to another, the rendering, like when am I done rendering kind of stuff, that's all in here. A capture class facilitates the recording lifecycle, you know, the start to stop, the in between of an individual capture. Encoders take a video frame's worth of data and converts it to another format. Scene is a, you know, the actual video sequence data that the user wants to capture, and then keyframes are the animations within the sequence. This library is very plugin friendly. So if you come up with your own encoder class, you know, you can just privately use that, and, you know, it could be like a server-backed one. There's so many possibilities on the encoders, and it will just work with the existing adapters, you know, the existing system. So it's very plugin friendly. I want to go a little deeper into the anatomy of the keyframe, since this concept can be new for a lot of folks. At the very bottom, you'll see a timeline going from 0 seconds to 2 seconds. And if you look at the timings object, you have 500 and 2000. You know, this keyframe that you have up there defined is the same thing as what's on the timeline. And I just wanted to show that, you know, if we're animating opacity and radius over time, you can kind of look at this timeline here and see that, you know, for the first half second, nothing's changing by the way this is defined. But then once half second starts, we're going to interpolate through the values and change them over time. And you can kind of see, like, you know, if we pretended that we're at the current frame right now, that would be the value. It's somewhere between like 0 and 1 and 232. And it's what the keyframe class does is it facilitates this interpolation. So you can just declaratively, you know, just define what you want to be animating and not really think about the inner workings of that interpolation. I wanted to go over anatomy of a capture too, since that's pretty interesting. You know, if the user says, hey, I want to start capturing, what happens, right? We think of real-time apps as normally just constantly requesting animation frames maybe, and constantly trying to do a 60 frame per second thing. And, you know, Hubble allows that to still happen in the background, but it does utilize DeckGL's kind of animation loop and timeline to slow things down and say, hey, let's actually define what we should look like right now. Anything that's paying attention to that will look a certain way at a certain time, and we'll just chug our way through. So you kind of just set the time to like 0 to start on the animation loop. What happens then is the keyframes get interpolated, state of things gets updated, you know, DeckGL viz state, deck layers, Mapbox, all that kind of stuff. That happens pretty synchronously, but it takes some time for that update to then be reflected in the actual visualization. So we have this asynchronous WebGL rendered step where Hubble will wait. Once that's done, we are going to take all the pixels and add them to the encoder. That's also asynchronous usually. Takes some time to gather that together and do the compression on the intermittent frame. And then the cycle will just continue. We'll just keep chugging along, doing the next frame until finally it's got the last frame done. And that last frame can either be the last predefined frame of your animation or just when the user interrupts. And when that happens, we may do some post-processing. In the case of a GIF, there's a lot of post-processing to compress the palette and all that. But once that's done, the output is a blob or a download. If you know, there's like a download utility just to help you download blobs built right in. So that's how a capture works. And then you know, how does this fit into the VizGL ecosystem, right? The way that this more or less fits in is it's something that you can use with DeckGL and Kepler GL. You could also use it directly with Luma if you're doing direct Luma, as you're rendering. But Hubble GL does rely on some components of DEC, the animation loop in particular, some components of Lotus GL. It uses the video encoders, and the idea is to put more video encoders, video builders there, because you get the web workers. Luma GL for its keyframe kind of engine system, and then I'm using Ocular and all that because it's using Ocular for the build environment and the docs website. It's a very VisGL aligned library. The repo structure from the beginning mimicked DeckGL. We're using Lerna modules, Webpack, Gatsby for static website stuff, Ocular for the build, tests, and all that. We have an RFCs area for new proposals. Currently using Travis CI. I know that probably needs to change soon. And ESLint, the same linting that DeckGL uses. There's very few third-party dependencies in Hubble. You mostly will just find some really good dependencies that we're bringing in for video encoder, like core video encoder implementations. We have one for WebM Writer, which is kind of based off Chrome's WAMI stuff. And then Lotus GL Video currently has the GIF builder, which is using GIF Shot. But we want to add some more builders in there and eventually get it down to where it's just Lotus GL/video for all encoders. We use Luma GL Engine, which is a very thin library for just the keyframe and animation stuff. And then Download.js, which is just a tiny utility to help you package mobs into downloadable things. We also have a series of recommended libraries for users. Pop Motion is really good for getting your easing functions. React for UI components is very convenient. React Map GL is compatible with our base map. We have examples of how to use that. DuckGL is very good for the visualization layers of things. And then if you're an engineer and you want to build something for users, patching this all into Kepler GL for the user layer is a great way to quickly add UI components on top of stuff. We have a docs website. You can check it out. There's a bunch of stuff on there that we're going to keep updating to make it easy to use. And then there's a few NPM modules. Today we have two, basically. We have the core module, which is the one with the minimum dependencies and no React dependencies. Then we have a React one, which has all the convenient components for fast integration. And then there's Hubble.gl, which is the package of packages. And then eventually we'd love to get into some animation enhanced DeckGL layers. There's quite a few ideas there, which brings us into the roadmap where, there's a lot of features that we'd like to build. There's WASM-based MP4 encoders or FFmpeg encoders that could be added in that we've started prototyping. I would love to make this all wait for map tiles to load. If you do a quick pan to another part of the world, and your frame gets captured before the map tile loads, it doesn't look super great. So it'd be great to get a waiter into that. Also, some folks want to load in a ton of data per frame or every few frames. And right now, you kind of have to have all your data loaded ahead of time. It'd be great to wait for data between frames for very, very data intense applications. The animation enhanced DeckGL layers that I mentioned, pure JS support. It's very clear that not everybody uses React. And so it is important to have a pure JavaScript implementation, especially when we get into the next one, which is Python Notebook or kind of PyDeck support. That environment doesn't use React all the time. And so it's just better to keep all that stuff thin. Kepler GL integration, again, it'd be great if we didn't have to know how to code to do animations. Magic keyframes, which there is an RFC out to explain exactly what I mean by that. But right now, as a programmer, you kind of have to anticipate all of the things that you want to animate when you're defining keyframes. Instead, it'd be great to kind of provide a more flexible library where you can say, I don't exactly know what the user is going to animate, but pay attention to these variables or these things. And whenever they do change, capture that into your keyframe and do the interpolation for me. DeckGL effect animation, this is actually pretty low-hanging fruit. Basically, DeckGL has some really nice blurs and animation. There's an effect prop that many might be familiar with. It'd be great to be able to do some keyframe animation on that to do transitions between clips. And then finally, keyframe editor React component. This is kind of still very early in the works on how that would be designed, but like as a user that wants to do more advanced keyframe animation, it'd be great to basically have a UI interface for that. And finally, where does this all go in the end? Like, what does the ideal state look like in the future? I think right now, Hubble GL does a good job at minimizing the special skills required to make animations. But I think where Hubble really needs to get to and where this stuff is going is we should be able to remove all the coding required to do animations. And that's why the UI components are such a focus of the library too. So we can spend all of our time on the creativity and the iteration, the work that matters when trying to communicate with people, because it's very easy to get kind of bogged down in the weeds of all this technical stuff. And that's it. That's Hubble GL. Thank you. I am open to answering any questions or having a discussion about anything you guys find interesting about all this.
Thanks, Chris. That's a very detailed review. I have a quick question about this. I think you're gonna talk about donating Hubble GL to UCF. What are some of the support that you think UCF can provide if the project it's accepted?
Yeah, it's a great question. So right now, primarily, I'm the only person developing this. And so what I would really love over time is to basically, with the UCF, get the word out that this capability is out there and encourage other folks to come in and contribute. There's a lot on the roadmap. I'm very open to completely, different ideas too on the roadmap. And so I would love the UCF to help kind of get the word out that this is a thing that we can be building together. And also, it sounds like, the UCF has like this great ability to facilitate a monthly meeting or meetings with the people that want to use this. And I would love to get to know more folks that want to use this and have a place where people can come to discuss and talk about the direction of the library and their use cases and stuff. So very much all on the kind of community engagement and community building aspects. That's what I'm really looking forward to with UCF support. And, also, I guess, I don't know how this would happen exactly, but, I have heard that UCF is good at helping facilitate collaborations between companies. And some of this video encoder stuff could have more kind of inbuilt browser support if there are folks that are interested in kind of collaborating on efforts like that. And so if there's anything that kind of gets on like really the bleeding edge of stuff, it'd be great to be able to kind of have help in facilitating a collaboration like that.
Yeah, and that sounds great. I think, you probably are in the meeting with a bunch of folks who are eager to integrate Hubble GL in their product. So, this is obviously the place and to get your project has more exposure and, obviously UCF can facilitate with your monthly open governance meetings if you want to, hosting any of that. Xiaoji and I can give you some points on how exactly that's done, get you jump started.
Awesome.
Cool. So I think we will have a vote. Before that, is there any more questions?
Yeah, so it seems to me that it would make a lot of sense to make this part of VisGL rather than a separate project, given how it links with the existing VisGL projects and also the open governance meetings that we have with that we have for VisGL include, for instance, we had the Chrome WebGL development team in the last meeting. We had NVIDIA also showing some type of video related solution, and so I think we have already really interested audience there. So that's just my suggestion.
Yeah, to me that sounds great. I think I am lacking a bit of context on exactly how projects are set up in the foundation, but in my mind, I really want this to find the best home for it to grow. And I was there at the last meeting too, and I definitely agree with you that that VisGL is like an umbrella that this, I mean, I was definitely designing this to kind of fit right within it. I just didn't exactly know what that looked like on paper, but yeah, I'm open to that for sure.
Drew here, a question kind of building on that is just as an outsider, I'd be curious to hear and also over time maybe see some materials come together online about all of these tools that fall under the well, it sounds like VisGL is a specific entity, but all of the different .gl projects, and just hear better understanding the menu and which fit together and which are kind of stand-in replacements for each other. So as you all reach out to other orgs that might want to make use or contribute, I think it would be very interesting to kind of flesh that out. And you know, if you have any rules of thumb for what goes with what, definitely curious to hear that now as well.
Id, would you like to
yeah,
to that?
Yeah, so kind of as the kind of lead, I mean, thought leader maybe behind VisGL, I think I agree. I think it would be good to have, we probably should create a web presence for, there is an old VisGL page that was hosted by Uber before it was transferred. I think that one could stand to be updated with more information. I think it also be, we wrote a blog post, I wrote a blog post when VisGL went open governance, and that one has been quite, I think, there's been quite a few big readership of that one. And I think maybe another blog post on the thoughts behind VisGL could also be helpful. So I can take some background action on that.
Yeah,
And
actually,
they all go into
wanna...
Kepler. Sorry, just a joke.
Sorry, what was
Javier. No, I said that they all go into Kepler.
Yeah, they're all used by Kepler. Right now, the kind of open governance of VisGL and Kepler is kept a little bit separate, right? So that's also...
Yeah, actually, on the point, I think it's kind of related to this. I have the impression that, like the whole idea about VisGL with TACGL, Kepler, yeah, like it's maybe a little bit confusing. It's confusing for me, so I'm sure it might be confusing for others too. So as we are adding more and more components, which by the way, this looks fantastic, Chris. So like I think we might want to consider what does bis.gl like means, right? Because people come for DEC or Kepler, and then there's like the governance board. So I find it all a little bit confusing.
Yes. Maybe I'm happy to help kind of try to address some of that. Is it a specific thing? Is it the relationship between VisGL and Kepler maybe that, or is
no,
it,
I mean,
we have a separate...
I think maybe it's just like a matter of, like branding and how we explain things and so on. So it's just about like, so VisGL kind of like seems to be like framework, and then kind of like compatible projects are in, and so the governance board of VisGL is different from the governance board of TACGL, are the same, like, well, you know what I mean? So where should we, for example, point around the governance board? Should we point to the governance board of VisGL?
Yeah, I think that, if the UCF is taking on, additional projects like MapSen and so on, I mean, we can't just add everything to one, governance board. So there has to be some separation so that we can have, focused conversations in the open governance. I think particularly with, Kepler, given that it's built on top of VisGL, you can have a discussion on whether that's separate. We have quite a packed agenda in the VisGL frameworks meeting. So do we want to add an application to that, or does it merit to have a separate discussion? I think that would be my kind of starting question, because, I think there is a different set of concerns around people potentially that are interested in Kepler than in the frameworks. But I find it hard to, so I mean, as new projects come in, they would either, you know, fall into a separate category, but in this particular case, you know, there's a Hubble-shaped hole in VisGL, and Hubble has been designed to work with GL, so it's a pretty easy decision. But in some other cases, it could be, you know, more.
Yeah, and I can add, you know, as kind of, I can put some flavor to the experience I've had in building Hubble over the last few years, and thinking about this too, because, you know, the structure, you know, the interest is, of course, to have this be compatible with as many things as possible, but also I want it to make a lot of sense when newcomers are coming in and trying to figure out what to do. And so I would say, like, definitely I'm still in the incubation stage myself on Hubble, where I'm having conversations with Ib and Shan around, you know, where is the best place for this thing to be? Because I would much rather actually remove something from Hubble next month and move it into, let's say, Loader's GL. I've done that with the like tar encoder, like a tar blob encoder that we had. And like continue that trend of like moving kind of something that Ib and I identified as something that would be better appropriate in another library, and like continuously extract that from Hubble and put it into the right place. And then similarly with Shan, you know, we've talked about where should the UI components go, and what are the pros and cons of them being in Hubble or actually shipped directly in Kepler. And we landed on there should be UI components that are compatible with DEC and Kepler, and anything really that can be in Hubble, and even Kepler could import from Hubble just fine for certain components. And so that's like a conversation that I've been able to easily have with Shan and Ib to like work out this stuff. But, you know, it's like, maybe there's a way to make that more clear to other folks too, like for the next project, how they can too also have those kinds of conversations and facilitate that.
This is Gail from Linux Foundation. I can offer a little bit of perspective on how different projects structure work like this. So, you know, urban computing, we're an umbrella, right? So we don't have an urban computing tech. We're kind of the umbrella for other to create an environment for other projects and technologies to live. And what I see other projects do, and we're still a pretty young project, which is why we haven't gotten to this stage yet, but other projects have that life cycle where you are incubating in the beginning and you kind of progress to a point where you're graduated. And the graduated projects often do have, they're much like Kepler and Viz, where you've been around longer, you have more contributors, more committers, so you do have your own TAC or governing model. And maybe the newer projects or younger ones haven't quite gotten there in maturity. So as a collective, those who are here as the overall TAC can help like foster that growth and help the project go from incubation to graduation, whether that is saying, hey, you can join our TAC for a while, and then as your community grows, you can have your own your own TAC to help govern that project. So that's kind of one of the ways it can work. Here, our kind of umbrella TAC that we have here, this is where you can really see and hear what everyone else is doing and how you can help each other's projects. And Javier, if you like, I'm happy to like at some point talk through the model more on one of these meetings or one-on-one with you, whatever is helpful.
Sure. I mean, I was just thinking, yeah, sure, to have that. But also, I mean, we can, I can also propose myself if it's needed, you know, to do any work on the website or anything, you know, for clarification. Happy to do so. So also, yeah, you know, we can follow up on that. If it sounds like you also might want to do something, so if you need help on that, or if I can help, I'll be happy to contribute.
Yeah, I'll do some thinking and maybe run some ideas potentially by you and maybe the rest of the TAC here.
It might be good in 2021 to take a look back at the project lifecycle for urban computing and seeing what needs to be refreshed. We haven't really used it very much, so it might be a good idea to refresh it and see how we can apply it to the projects that you have now.
That sounds good.
Are there any additional questions around any Hubble GL tech? Anything that was a little confusing that I could clarify?
Drew here. I'll ask just maybe a cheesy question. Do you have a favorite browser and rendering engine and a least favorite at this point?
It's a fair question. Yeah, I would say Chrome is my favorite because of the whammy stuff with WebM support. I don't have a least favorite. Well, I guess what Safari doesn't really support WebGL 2 yet, right? So that would be the one, at least at this point. But yeah, I think that might be kind of like separate from Hubble itself, since it's more just what can you render. Yeah.
Great, thanks. And thanks for a good presentation too.
You're welcome.
All right, we only have 10 minutes left, and let's go into the next agenda on the list, which is talking about the Mapbox GL going closed sourced. And, you know, I'm not just gonna, I'm just gonna open this to everybody who want to chip in on this idea. I think some of the background we have been talking about in the email is that, you know, maybe Urban Computing Foundation can support a specific open source version or a fork of the Mapbox GL JS. And, you know, Javier, I think Cardo has put up a post about your thoughts around there.
Yeah, so if you want, I can also get started. So you guys know by now all the things. I think, you know, like the new things is that we probably know now also a little bit more about why the decision to go commercial based on Amazon location and, you know, some of the launches that happened this week. So, but but in any case, I mean, the fact is that Mapbox GL is, I think, very, very heavily used. It's probably right now the most used based library for base map rendering, and there's, although we claim in the TechGL world and so on to be like the couple, and it is, and you can use other libraries, the reality is that there's a lot of users and there's a lot of overlap of, you know, use of TechGL with Mapbox GL. And so here, you know, we could see also with Hubble. So the question here is, you know, it's like this is having an impact obviously in a lot of open source and companies in there. There is one fork that has already been started called MapLibre, which seems to have taken some of the traction already on it with companies like Elastic and Microsoft already. Carlyle seems to be in a way Carlyle. And I've talked with others, it sounds like they might go that route too. So so that's happening in one side. So I don't know if the Urban Computing Foundation should do anything around it, but it sounds like this is a piece of technology that is used in many different places, and that right now is quite orphan. The MapLibre fork is actually looking for getting incubated in the OSGeo Foundation, and I don't know. I thought it would be appropriate to talk about this. I mean, our opinions is my opinion, my particular opinion is like I understand why Mapbox did this. It is in a way unfortunate that, you know, it happens so long to the point that right now there's a huge dependency on Mapbox GL overall, and that, you know, and I don't think, you know, like there's a lot of journey to have any kind of like I would say like comparable kind of like library in the open source world now to what is available on Mapbox GL. So so that's the thing. Oh yeah, here is MapLibre. So this is the fork that I'm mentioning, and I don't know. I mean, like, just wanted to hear if, you know, if this for me, for example, could be like a place where we could, as a the Urban Computing Foundation, could potentially kind of like put some funding to help on some parts, but it might also be a little bit of, you know, like politically problematic considering. So just thought we had to, and that's it.
It seems to me that it would be really good if this MapLibre went into a foundation. Now, I think Mapbox is a really important geospatial player, and I'd like Mapbox to be, personally, I'd like Mapbox to have a good view and relationship with the UCF. And so, you know, Mapbox may not like the UCF if it focuses on these things. I don't know.
Right. So the UCF does have Tangram, which has some activity on it. I mean, I wouldn't say it's a lot of robust commercial activity necessarily, but the lights are still on there a bit. I've been considering getting a bit more involved with some projects that are happening, but yeah, it's just like the Amazon blog post that went out, like Javier mentioned at the beginning, didn't mention that. So yeah, I don't know. I'm not sure. I'm just wondering, do people here, I'm curious, just like a show of hands, or would people have interest and ability, and would it be commercially viable for them to work on a core rendering engine? Like any companies or individuals like on the call right now? Just curious.
What is that? I actually don't. I'm not really familiar with core rendering engine or the earlier thing.
Sure. Yeah, for sure. So what's happening now? So Mapbox.gl, there are native libraries as well as web, right? So Kepler and others use Mapbox.gl for the web as the core rendering and the core map rendering engine. But there are others, right? Like Here Maps has one, Esri has one, Mapzen had one, which is now part of the UCF and has some light activity. I don't think like a lot of commercial activity necessarily. Although, actually, I think some companies are using it now that I think about it. But yeah, I think one of the questions is what role, if any, do we want to play in doing something like that? It's amazing that still works. I'm really impressed. I mean, the tiles behind it. I mean, not the rendering engine. So, like, the question is, like, like one of the things Javier is bringing up is Mapbox has switched the license on their previously open source rendering engine. So what, if anything, do we want to do? Anyway, I know we're coming up on time. I'd love to hear from people who are interested in co-developing something like this that is in the open. I don't know if it would necessarily be a fork of Mapbox, but maybe other things that we already have within the foundation.
It'd be, I actually talked to some people behind this stack probably a year and a half ago. I don't remember the names exactly, unfortunately, right now, but there was a certain interest in moving this onto LumaGL, which is the WebGL rendering engine underneath DeckGL. That this code is using very old raw WebGL code, and that could be a first step. And so I think from my perspective, if there was some kind of investment in this that brought it more in line with LumaGL and DeckGL, then that would really leverage the fact that these things are in the same foundation. In Deck, we have already, we use Mapbox as a base map, but it's always had limitations. And, we have done 3D rendering. It only recently did, in the V2, did Mapbox add 3D rendering. We're also doing globe rendering in DeckGL, and Mapbox can't do globe, so we have to do our own base map anyway. And there are a number of other use cases where, we need a different solution. So, but I think it's a fairly big investment to go into and make an overhaul of this project. And so it seems to be a chicken and egg, but it'd be very exciting to get this, that'd be, I think, one of the best ways to really make this live again.
Yeah, so Drew here, I'll just add a couple notes from our side. Is at Interline, we've been making use of both Tangram and Mapbox JL.js more as users than as power developers, but they're both definitely useful options to have available. I do think the conversation is simpler when we just think of Mapbox JL.js 2.0 as a totally different product. Like it has, it introduces some new functionality. The code base changed a lot, and maybe after all of this settles down a bit, this MapLibre fork can be seen as just a somewhat not as a fork of Mapbox JL.js 2.0, but as one of many options. I think that will, whatever its official home, I think it will kind of become a little bit more neutral, given that Mapbox won't have continued involvement there and that they've already gone on to a bunch of other technical priorities. But yeah, in any case, we're definitely watching this MapLibre fork and curious to see where it goes.
I think it's a very healthy way to look at it, and that's also kind of how I've been thinking about it. That it could just be its own thing. I mean, one thing that I've never quite gotten clarity on, so maybe people here actually know more about this, but the Mapbox GL.js is it primarily a WebGL 1? Like they don't really have WebGL 2 support. Is that like architecturally? Do we know?
It's for V1, that's true.
Yeah. Yeah, so I've never actually thought of it as like kind of the bleeding edge base map tech from a tech stack point of view. It's very pretty though. You know, the studio that Mapbox provides to be able to customize the vector tiles and all that. Like there's a lot of value that Mapbox has brought in with kind of the ecosystem around their base map renderer. And from in some point of view, it's like, okay, yeah, like they've done a great job with their product there. And if that's the base map style that someone wants to use, I just see it as like the option there, but there's so many others. Like, you know, Carto has tons, and there's tons of base maps that are now compatible with DeckGL. And
this is Chris. So it's a little bit more complicated. It really is an incredible piece of work and an incredible piece of investment. There's been a huge number of engineers working, you know, to have like a library that can handle labels in the way that it does and so on. So it will take a very, I mean, like, well, probably no one better than Randy here can tell what's the effort level needed to have a, you know, like a quality like base map render to the level of that Mapbox GL has right now. It is a very, very substantial investment. So and not available to many companies in the sense of like there's not that many WebGL probably experts that can do this type of cartography. So it is not gonna be easy to be replaced for quite some time if there was gonna be, you know, like a new product, even you're using more modern technologies and so on. So yeah, but if I'm hearing, you know, from all of you, I think you're like definitely the Urban Computing Foundation, from my point of view, and we put it in a blog post, has to stay independent, because there's not going to be a world, you know, where, you know, just one will fit for everything. There's Google Maps, there's OpenStreetMaps, there's here, there's, you know, now there's never been so many base map providers as there is right now. So we definitely, the world has to gonna have to be, you know, quite, you know, like independent in that sense. And I think, you know, probably, I mean, like, yeah, from what I'm hearing, you know, probably the Urban Computing Foundation, what should do is, you know, ensure that the DeckGL and, you know, like world in a way, I mean, like the BCL remains base map independent in that sense. And, you know, not, you know, like, and probably I do agree. I don't know if, you know, we should maintain Map Libre. That will that will be not a very good move. I mean, and there's already Tangram in there, so maybe it's just better to just kind of like let it go for some time, see how it evolves, and just make, you know, some sort of like a statement in the form of a blog post around, you know, we just promote basement plurality, if you want to say.
Yeah, I think that makes sense. If anyone on the call is ever in a situation where they're like, hey, we need to do some core development on a rendering engine, I would just be curious if you want to reach out to me. I would just like, just to see, maybe it's not part of the Linux Foundation, but maybe it's specific companies, and maybe there's a way to work together, whether here or elsewhere. But yeah, let me know. I'm just curious if people get to that point.
I'd be happy to support from VSGL perspective. All right.
Right. I think we are running over time. So thank you guys for coming for this meeting. And it has been a very productive discussion. And thanks, Chris, to come present to us as well. And, you know, we'll send you a form to fill out so we can start a vote on this.
Thank you.
All right. Thank you, guys.
Happy holidays.
Yeah.
Thank you.
Thank you all. Happy
Bye.
holidays. Stay safe.
Holidays.